Hello everyone, welcome to Binary Broom and selection sort. Selection sort is not the most efficient sorting algorithm in the world, but it is known to be pretty simple and its algorithm is pretty easy to understand. So it is quite recommended for those who are starting to learn algorithms and more specifically those who are learning sorting to start with selection sort. That's why I'm bringing it here. Okay, let's get started. First, let us imagine a list. For example, 1, 3, 4, 2, and 5. Imagine this list. Clearly, it is not sorted. The way we are going to sort this is that we are always going to separate our list into two sections, two sublists. The first sublist is going to be our sorted sublist, the list that everything inside it is totally sorted. And the second sublist is the list that we are always working with, which is those elements that are not sorted yet. And how we are going to do this is that we are always going inside the unsorted list and we are looking for the minimum number. And when we found the minimum number, we are going to add that minimum number to our sorted list at the end of our sorted list. And since we are doing this every time, the sorted list will be always sorted, and at the end of the day all our list is completely sorted and we are good to go. So let me show you an example. For example, when we are starting to sort this list, we look for the minimum. At first we don't have any sorted list, so the whole list is unsorted. We look at the first number, it's 1, so first we set our minimum number to 1, and we go on. We look at 3 is not smaller than 1, so we go on 4, 2, and 5, and when we reach the end of the list, our minimum number is 1. So we add 1 to our sorted list. Since the 1 is already at the beginning of the list, nothing changes. But if 1 was like here instead of 2, and 2 was at the beginning of our list, we needed to swap these two numbers and bring 1 to the beginning of our list. So 1 is here, and now our list is now separated into two parts. The first part is our sorted list, which starts from here. This is our sorted list, and the other part is not sorted. Now we again look for the minimum in unsorted section. So we look at the first number, it's 3, then we look at 4, 2, and 5. The minimum number is 2. So now that we found the minimum number, we are going to swap it with the first element of our unsorted list, which happens to be the end of our sorted list. When we swap these two numbers, we are going to have, let me bring these all back, we are going to have 2 here and 3 here. And now the sorted section will be 2 elements and unsorted section will be 3 elements. Then we are going to look for the next minimum in the unsorted section. We look at 4, 3, and 5, and we find the minimum of 3. Then we swap 3 and 4, and what we get is 3 and 4 here. Now our sorted section will be 3 elements and unsorted will be 4, and we go on till the end that the whole list is sorted. Here it is sorted already, but it could not be sorted. Like if instead of 4 we had 6, here we would have 6, and then we needed another swap to get to our sorted list. And yeah, that's pretty much the selection sort. We also have the implementation of its algorithm here. Since we had two lists and we needed to update our border to understand where the sorted list is and where the unsorted list is, we need two loops. We need two for loops. The first loop is going to control our border, the border between sorted section and unsorted section, which at first is 0, which means we don't have any sorted section, and it's going to get a +1 each time, because each time we are going to add another element to our sorted list, so the border needs to come forward one element. That's the first loop. And the second loop is going to look inside our unsorted section and is going to iterate over all elements and find the minimum number. And let me mention this, that uh, we're going to suppose that our first element of the list is our minimum, and then we look to the other elements and we update the minimum number. At the end of this loop, we have already found our minimum, and in this section we are just swapping those two elements that I mentioned. One is our minimum and the other one is our border elements, the elements that is in the beginning of the unsorted section and is going to be added to our sorted section. So when we swap these two, we are actually adding another element to our sorted section, so I needs to be incremented, and we have a new element in our sorted part. And at the end of this operation, the list will be sorted completely. I have an example here as well. Imagine this list. I'm going to give it to this function that I just explained, and the output must be sorted. And as you can see from the output that is down here, it is totally sorted. But I'm going to run it again so that you can see that the output is totally sorted and the input was not sorted. And yeah, that's it. We are going to look to other types, I don't know, let's say other algorithms to sort in the future, and hope you enjoy.